Hey guys, my name's Colton Hale. We'll be looking at some spectroscopy again today. Alright, so first we're looking at the mass spec of the molecule again, C8H8O2. So we find that the molecular mass is 136, which is what would take all of our measurements from 136 minus 119, 107, 92, 77. Here, 135 is the base peak. So technically we don't need to go past, but since everything is past it, we will look into it. So first here, 119 was found to be a difference of 17, which is correlating to nothing at the graph. 107, 29, which we got a C2 H5. Next one, 92, was a difference of 44, which we know cannot be the CN with also an oxygen and two hydrogens cannot be because we have a nitrogen here. And then 59, difference of 77 here, or difference of 59. C carbon, we got an ether here and a double bond to O and 3 hydrogens. So that could be useful later. Next to the degrees of saturation here, we got this formula of 2 times the number of carbons plus 2 plus nitrogens minus hydrogens minus halogens divided by 2. So we got 2 times 8 for carbon plus 2 plus 0 for nitrogens minus 8 for hydrogens and 0 for no chlorines or bromines, anything like that. Divide that by 2, and we should get 5 rings or pi bonds, which is a very strong correlation to an aromatic. Next, we will look into infrared or IR, and so basically we're going to look at all of these different little peaks here with the numbers down at the bottom, and I have them all written out right here. We're just going to work left to right here. So this first peak was found to be a carboxylic acid or alkene aromatic, along with 3010, the next one. And then the third one, 2934, carboxylic acids and an alkane, 2839, same carboxylic acid and an aldehyde, and again, same with the 2743. And then this next one moves down here, 1684, found to be an aldehyde / ketone, an ester, or a carbonyl, carbonyl, which could be very useful with the 2 oxygens. 1599, aromatic alkene again. 1261, haloalkanes, esters, ethers, alcohols, and carboxylic acids. And the last one is again an ether, alcohols, and a carboxylic acid. So we have a very strong correlation that we are going to have some type of ester or ether within this molecule. Next, we look into proton NMR. And so first we look at these peaks and the integration numbers. So we have 1 hydrogen here. This peak integrates to 2 hydrogens. And again, this one integrates to 2. And then finally, the last peak integrates to 3 hydrogens. So we look into the placement of these peaks within the graph. And this first one right here, the 3 correlated to 3 hydrogens. 3.9 is found to be an ether, which correlates to this. And the hydrogens, 6, 7, and 8 that it integrates to, are right next to the ether. These next 3, 7, 7.2, and 7.8, all came to be an aromatic, which we have here at 2, 3, 4, and 5, all off the aromatic. And then this last one here at the correlated to 1, at the 9.9 position roughly, was found to be an aldehyde, which correlated right here next to the aldehyde. So that is the positioning of our hydrogens within this molecule. Lastly here, we will look into carbon NMR. And so first, we have this 1, which is correlating to the aldehyde, the carbon bond to the aldehyde, and the 1 hydrogen coming off of it. Next, the 2 position carbon, around here at the 164.5, was found to be the aromatic region, so right off here. 3 and 4 very close together, also off the aromatic, 3 and 4. 5, 114.2, aromatic region again, which we see right here. And then 6 and 7 were correlated together right here, which were also off the aromatic. And this correlated to 6 and 7 because there's very thick and it is the highest one on the graph. And then this 8th carbon, which is bonded to the right here to the ether at 55.5. Just a one CH3 within this molecule, so it's the largest carbon-based molecule, I guess. So that's why it is shifted least farther, or least downfield. Alright guys, thanks for joining along for another life lesson here. I'll see you guys soon.